Hello. Okay. Um, Today's project is gonna be a little bit special. Now, in the past, I have created let's just say a password manager. Yeah. I don't have any photos for it, but just have to believe me. So, because I recently bought a mechanical keyboard. Let me just check. Oh, forgot where I put it. Yep, so I recently bought a mechanical keyboard and they gave me 2 extra mechanical switches. And I thought to myself, how about I create another password manager, hardware password manager, but this time with an added functionality. Every time I rotate a rotary encoder, the mechanical switch will do different things. So for example, in Visual Studio Code, this program right here, the macro, let's go to the hardware macro. We'll use that button for copy and pasting code, for example. But in another program, for example like FreeCAD, I will map it as a button to, I don't know, some obscure shortcut like measurement and stuff like that. I have always wanted to make something like this, so let's make that possible. Now, this video will strictly be about the hardware aspect of the project. The software and code I will give you later, right after I review it, to make sure I didn't accidentally put any of my confidential password or any of my personal password on there. Just a precaution. Now, let's go over the hardware a little bit. So for hardware, I will use the Arduino Leonardo with the USB mouse. So let me just check it real quick over here. I think it would be better if you got an image of the thing. Okay, just pull over the web browser. I think this one. Now I use the Pro Micro for the password manager, and there's a ton of I/O left for me. This is a micro USB version, micro USB-B version. So yeah, I don't like it. There is also Type-C version online, of course, not that one. Type-C version of that board online. So if I'm going to make, like this one, but they're out of stock at the moment. So just go online, Shopee. If you guys have a credit card, you can go to Taobao and stuff like that. So no, not this one. This one. So price is nearly identical, but you can see on the top row there's the 11, D10, D9, A0, A1 and A2. Those are the I/O pins, and on the left there's 5V ground, and on the other side there's SCL and SDA for I2C communication. And yep, I2C is gonna be pretty important in this project in terms of expandability. So let's go for it. Now I'm gonna use this board, and as you can see, it already have a male USB port, which means I can just plug in an extra adapter cable or extended USB cable and use this thing. Alright, so this board is much smaller than the other one, which means we can design a smaller hardware footprint. And for the screen, where's the damn screen? Okay, I am using this screen because this is what I have around me from past projects and stuff like that. So this extra monitor, I haven't do anything with it much. I want to make use of it now, so it stopped sitting in the bin sadly. So luckily I double checked the dimension, and these are the correct dimension. I will design a 3D printed housing for this screen, so it looks better, it is better protected and looks more professional. For the mechanical switch, there is the, I think this is the official datasheet from Cherry, and yep, this is for the PCB. Oh wait, no, this is for the PCB. I'm looking for the mounting plate. I think it's just 14 by 14 millimeter, as I have checked with my caliper. Let's double check that again. So because this thing have a notch, should measure right here. Yep, 14 millimeter. All right. So a 14 millimeter square to mount the switch. Yeah. And of course I will use the rotary encoder. I will measure it. All the screen mounted at 45 degree. PCB not needed. I'm just gonna hand wire it, or just wire it into a perforated board to mount the component. And I think that's about it. Let's get to it, right? Okay. Alright, now I want to first start with the component mounting plane. So this, I will mount everything to it. Let's create a rectangle, center rectangle. I want it to be a bit long, so let's just see how long does it need to be. 50 millimeter, is it enough? No, I need to accommodate for the screen, so 10 is a bit much, huh? Yeah, 10 is a little bit much. 7 is a lucky number, so let's just go for 7 millimeter, 70 millimeter in length. And let me just double check it. Single switch is big, right? And 30, no, 40, yeah, 40. I'm not Chinese or Japanese, so I don't have any problem with the number 4. Okay, 40 millimeter by 70 millimeter. Okay, that will be the dimension of the top mounting plate. All right, and I will also create an additional with the dimension 14 millimeter by 14 millimeter. Same for this one. Okay, now I have two of them. These two things, these 2 points shall be symmetric to the center axis. Nice. Okay, it's a bit cluttered, huh? Gonna put everything in because I want the switch to be at the bottom. All right. I will need an additional point on the y-axis. Perfect. I will add a dimension to this point. Let's give it 10 millimeter. These 3 points will be horizontal constraints, so I will press the letter H on the keyboard. Perfect. Now it will be constrained on the horizontal line. Alright, and I will add another line over here. These 3 lines will also be constrained horizontally. Okay, so this point is constrained without needing to add another number. And these 2 points will be symmetric to the center point. So okay, it is perfectly centered. All right. Okay, we got that one down. let's get the measurement of the rotary encoder now. Now, give me a second. .5 is the perfect dimension, but I'm gonna go for 7. Yep. Gonna go for 7. So I will need a 7mm hole. Alright. And should I add in? I want to add in a resistor, but I don't know what what I can do with that. I intend to use the rotary encoder already. Just the rotary encoder is good enough. Yeah, I want it to be dead center right there. So how can I make it over here? Or should I give it a little bit space, because there is this thing and there should be a knob around it, right? Yeah, usually a knob around this thing. So let's give it a bit of space. Coincidence. Alright. So it should take this much. Knob is gonna be a little bit bigger, and the rest is for the screen. Alright, we got the top mounting plate. I believe that is correct. I'm gonna press E on my keyboard to extrude. This is my personal setup. And oh my goodness, I forgot. Give me a second to Google this stuff. 1.5mm. Is it true? I have crush issue with AI, so right, 1.5, so let's use that number. So I will extrude this thing by 1.5mm. Right, beautiful plane. Right, now for the screen. I wonder if I should make it slanted at 45 degrees. Or I should just make the whole thing, like instead of making the screen rise up at this angle, should I just make the whole thing angle up like this? You know what? Okay, let me check a little bit, because when we mount the rotary encoder, it will bump up by quite a bit. So let's measure that. The length of a shaft. Okay, so around 20. Okay, 18 or 20mm. No, almost 20mm. So we'll give it a bit of a rise. Let's give this thing rotary encoder and what the got it down. Now how do I make this thing? I'm gonna go over this plane, and create a datum plane. Right, I'm gonna create a sketch based on that datum plane. No. I like it this way. Turn off the plane, and GX is the keyboard shortcut to get to reference external geometry. Now, just a bit of water. All right. Because it will rise up by 20 millimeter, adding a couple more millimeters, so like I'm gonna go with like 25 millimeter. Yeah, no. Just give it 20. Nice round number. I want to make something a little bit like this, and this, and this, and like this. Okay, sort of a triangular wedge that the screen will mount it on this surface. If you catch my drift, because this thing is vertical. Nice. This thing across tangent. Now I will need to, alright, let's make it, should I make it dead center? Oh, I have to constrain the height of everything, right? So the height of everything, I will press D and input 20 millimeter. The screen should not rise higher than 20 millimeter, the top of the screen. And for this will determine how. Okay, I prefer something symmetric, easy to constrain. So I put it dead center like that. Boom. I will extrude it. Of course, maybe in the reverse direction. 40 millimeter, or better yet, up to this face. Okay. Fuck. Okay, I'm a goddamn idiot. GX, this thing, this one, vertical constraint, this one, adding another point, tangent to this one, and this one should coincide with the letter C. This one should be symmetric around this point. Boom. And this length should have a dimension of 20 millimeter. Boom, baby. Let's go. Now we're talking. Extrude, reverse direction, up to face, this face, and press OK. Much better. And because this is just the mounting plate, oof, boy, this part shouldn't be so thick, huh? Let's fix it. Should I make it? I should make it hollow, right? Okay. How should I make it without setting any constraint? what is that angle from this one to, I think I do need some constraint. No, this angle and this one currently 48.81, 48.81. I should, oh no, this one and this one should have a thickness of 3mm. Oh my goodness, 3mm is so much. Let's give it 2. Oof, still quite a lot, huh? I think, yep, let's just stick with 3mm. A bit much, I know, but this and this should be also 3mm. This and this should also be okay. We have redundant constraint already. Can I just delete that one and add a constraint? No. Okay, it doesn't let me do that, huh? How do I do this? Or I should make GN. Okay, I'll create a line. Yeah, sure, this one should be vertical. No, I wanted to just tap it right there. This line and this line should be vertical to each other, so 90 degree, and I should press N. Yep, perfect. Yep, perfect. Okay, not so much. Okay, let's do that again. We have a construction line like this. These two should be 90 degree, and also these two should be 90 degree. Alright, now we got it. The dimension of this one is 3mm. Nice. We have which part is still moving? Oh my goodness. Let's constrain the geometry line. What the yep, think I pressed something wrong. Close it. Wow, what a thick boy. I do think 3mm is a bit much for this thing. Let's knock it down. It was 1.5 before that, right? Let's give it and I don't know, this part shouldn't exist, to be honest, so I'm just gonna delete it and allow it to be tangent. This part over here is also 1.5 and close it. Oh, wait, what? Something's wrong. I can fail it. Oh, I think I see the problem. I will turn this thing into a geometric line, so like GN, and then apply the tangent constraint, because there are two lines overlapping and it shouldn't happen. 1.5. Now because geometric line don't get rendered into an actual object. Now what the heck is this? What was the error? Wire not close. Oh, okay. I'll close it myself. Going to break some constraint, I know, but let's delete that line as well. GN. I will use a construction line. Yeah. This line, this point, and this point should be symmetric. This point and this point should coincidence. This point and this point should coincidence. And now we got a better one. Wunderbar. Okay. All right, now how do we make it better? The dimension. I'm gonna stop a little bit. No, let's not stop. Let's keep going. Got to switch down. Got the microcontroller down. Got the rotary encoder down. I think I'm down for everything. Now I will have to model the screen. So let's get to it. Set up datum plane. Okay. Turn off the visibility. Create a sketch on the datum plane. Turn it off. Yep, this is the intersect point, so we need to GX. Select the boundary of what we are working around. Perfect. Center rectangle with the dimension of 21.744 by 10.86. Wow, it is that small, huh? Okay, that's what I want. I want the screen to be symmetric, so create some additional line. This one and this one, they are fully constrained. This point and these points will be symmetric around this point, perfectly centered. Nice. Alright, this is just for the screen, so the inside area. So the inside area only, and we need to sketch the mounting screw around it. Why don't they give me the area, just the value of the mounting screw? Gonna go GN. Yep. And I will sketch the outer parameter, so 27.5 and 27.8. Okay, I think we are having a bit of a problem here. Okay, I will need to rethink the strategy right now. Maybe setting it dead center isn't that great of an idea. How can I do this? Oh no. I can edit the sketch, make it a bit taller, maybe. Quite a conundrum I'm getting. Or should I just change the overall design language of this thing? I kind of digs this design, but oof, well, quite a bit of problem I'm having. So let's I don't want to make it taller than it needs to be. The screen is comically small. So you know what, fuck it, let's finish version 1 first before we do anything else. The cutout doesn't look too bad if I were to extrude it, but I think I do need to make oh nice, it is still attaching. 30 is a bit more than it needs to. Might have overdone it. Hold shift. Now, how do I create a mounting hole for this thing? Let's make it smaller. I don't have enough space, you know, to make it big. Yep, still buried inside. Nice. 22. 22 is the magic number, baby. I think I do need a bit of googling. Says right here that distance between the hole is 22 millimeter. Somehow checks out. What is the diameter? Oh, I must be fucking blind because I cannot see anything. Let's just measure it. It might even be faster that way. Or better yet, I will measure the screw. The screw is actually a tad bit smaller. There's a lot of wiggle room, but I'm gonna try to measure it anyway. It's usually faster. So this one is an M2 screw, but even for 2mm it still have a lot of give. Yeah, it still have a lot of give. 2.5 is way too big, so like 2mm mounting hole will surely give me quite a bit of wiggle room over here. Right? 2mm it is. Two millimeter, 2mm, 2. Distance between it is 22mm. This one horizontal constraint. Distance of 22mm. Alright, I don't think this is the correct value. Let's double check it with the caliper. Oh, I'll be damned, it does look like the distance between them is 22mm. Huh. 27.5 is it? Yep. Oof. I mean, on the real scale on my caliper it is only 27, and on the height I think I only tell 28. What's going on? Right, 20mm it is. I don't have enough time to care about it. 20mm, and the other one is also 20mm. Alright, okay. Vertical constraint. Vertical constraint. Horizontal constraint. Symmetric along this axis. It can still move up and down, huh? um, I'm having trouble. The dimension everything. I don't think this dimension is correct, to be frank. I'm gonna have to measure it myself. I don't know, it feels like this thing is actually 23 by 23 millimeter. How do I even mount this thing? Oh crap, I don't even care for it now. Just gonna measure the real thing. So horizontally this thing is 27, not 27.5. Yeah. And vertically this thing is at 27, like 28 vertically. Very close. This thing actually just need a single constraint to lock in place. Let's give it this one. No? I really don't know what I'm doing right now. What should I do? This thing only needs a vertical constraint. I am trying to give it one. Let's give it 3. Nice number. Okay, those will be the mounting I want to get rid of this thing over here. Oh, I should have done it from the start, you know. Now I feel stupid. Okay, let's just save it. Okay, now I got that one. I'm gonna delete everything else. How do I keep the sketch for this thing? I want to remove the operation but still keep the sketch. Yep. I want to keep that sketch. Yes, it will be broken, I know. But the sketch 01. Okay, delete that one as well. I'm gonna try to attach the sketch to another plane, so like the XY plane. Can I copy the... It is working now, but I want to copy all the sketch data, move it to this operation. Just paste all of it in. Nice. Of course, there isn't any constraint that hold it in place. Let's fix it first. This thing and this line should be coincidence. This line, this point and this point should be symmetric to the center point. Move a bit less now. Now we need to settle this. I will put this point and this point to coincidence. Close that. Remove sketch 02. Now we got a plate that we can start mounting stuff on. And gonna go to File, Save As. Let's give it version 1.1. Anything could be wrong with it. No. The glass. Oh shit! I forgot this thing has a piece of glass. Plastic, acrylic. I don't know, but it is sticking out. Oh. Okay. Change the plan. Yeah, not that big of a change in plan. We have to sunk it a little bit down. Right. Let's try. I'll try printing this version out. And yep, I think this will be the first version to check out the whole arrangement and stuff like that. I will have to also calibrate my printer again because I haven't calibrated the dimension. These holes always come out too tight. If I have print this thing at 6.5 millimeter, it would not fit the rotary encoder. Yeah, so I think that's about it. Got a switch, got the encoder. I think I should make a bit of a area down here that allow it to hold everything. So that is the mounting plate. Now we will create another body. We will call it box. Right, I'm gonna hide the selection. Should I hide it? Yeah. And I will create a sketch on the XY plane. I will first create the box, right? We need the box for this thing. Now what kind of box should it be? I am thinking of a box that is wider than the lid, so that the lid can sit inside the box. So oh my goodness, that's 40, right? So I'm gonna have to make it a little bit bigger, so like 46 for the inside. I'm talking about the inside dimension of the box. 40, 46, boom. 70, 76. Right, so that is the inside. If I turn this on, I really need to rethink this thing. That should be the outside, right? Yeah, that should be the outside. The inside should stay the same. So let's give it another sketch. 40 by 70. Close that. I will press E to extrude on the other direction. How much should I give it? 3 centimeters. Seems like a bit too thick and unnecessary. Let's give it something smaller, like just for the wiring and the thickness of the switch, right? So the switch alone should be about 10 millimeter already. How big is this microcontroller? Much bigger. Alright. Gonna give you a bit more room. 15 millimeter. That should work with. Yeah, I think that should work. 15 millimeter should suffice. That is the wall, and another sketch on this plane with a smaller inner diameter. Wait. 40, 70, and smaller one, 37. No, not 37. What? Oh, 36. No, 34. 70 instead of 70 it should be 64. Right, close it, extrude it in the reverse direction. Where is it? Okay, let's give it modest 3 millimeter. Okay, this does not seem like a very smart plan. I'm gonna change that a little bit. The sketch should be offset, right? Okay, I have offset it a little bit so that this thing can sit flush. Let me check if it is flush. So there's a gap, there's a wall, and there's the support, the flush mounting. 3 millimeter seems very big in this this sort of scale. Wait, why do I even design it like that? That is stupid. No. Delete it. Cancel. So stupid of me. The inside, right? Make it 34, 64. Close that one. Of course, it will not fit. If we check, yep, it will not fit. And now we add another sketch on the XY plane. Wait, what? Sketch XY plane, yep, but this time we are creating a cutout 40 by 70. This is much smaller, by 67, 64, 64. This one is correct, right? Gonna shift extrude to pocket it, reverse. Wait, where is it? Wait. Stupid me. Turn this thing on. Oh my god, I have been sketching on the wrong. Never mind, just delete it. What is this? Okay, just delete, just stop. Make this one active body and cancel. Okay, now I'm going back to designing back cutout pocket for this thing. I'm thinking just a simple cutout slot. Yeah, just a simple cutout slot for this thing. Or I could just blow the entire back. Yeah, I will also need to make some PCB mounting, a perforated board mounting holes. But the first version will likely just consist of hardwiring it directly to my microcontroller and plug the USB cable deep inside it. So I think I will model this thing based on the dimension of the USB extension cable. 1 second. We can just create a hole that is 18 by 12. So let's create it. All right. Can I quickly center this thing? I would like to center it using the dimension. Without having to use any dimension. Gonna draw a line from here to here, which is just a connection. What is it? GY, okay. Nice. This point, and this point should be symmetric. I didn't even need the point over here. Oh yeah, wait, I did need it. Okay, I'm gonna chamfer it a little bit. Might not even need to, but well, I think, sorry for the noise, I think it's really powerful that you can just sketch a simple thing like this, and well, got it done in like, holy shit, over an hour. Yep. So a bit over an hour, so you got this thing. So let's wrap this up. The journey of 1,000 miles begin with a single step, so stay tuned for my next step. Thank you for watching. Oh, I should do that, like, the journey of 1,000 miles begin with a single step. Be sure to stay tuned for the next step.